Okay, brother. See, we have this data given in distances in nautical miles and time is in minutes. Here we see the first step. He asks us convert each number in nautical miles into kilometers in a separate column. So let's do this distance in from nautical miles to kilometers. So we knew that. Let's take it. Yeah, so you can easily understand. So we are converting the distance given in the nautical miles into the kilometers, and we know that 1 nautical mile is equal to 1.852 kilometers. So we can know 1.852 kilometers is 1 nautical mile. So when we multiply with 11.12 nautical miles, it is converted into a distance of kilometer. Just drag it down like this. So it will automatically convert these values in nautical miles into the kilometers. Similarly, in the second step, he asked us to convert the time in minutes to hours. So time in hours. So we know that in 1 hour there is 60 minutes. So when we convert from minutes to hours, so we divide every number by 60. So these minutes are converted into hours. Similarly, drag it down so that every minute given in minutes is converted automatically into the hours. So we already have all the data available now. So just we need to transform this time in kilometers, distance in kilometer and time in hours to a third step, which is equal to the speed. So we need speed in kilometers per hour. Speed in kilometers per hour. So we know that speed is the distance traveled per unit time in hour. So this is the speed in kilometer per hour. So I convert it like this. Just drag it down. You can also drag it down. So we have this, drag it down. It automatically convert each value here in column F6 and divided by G6. You can see F6 over G6, F7 over G7 automatically converts it. So we have this data. Now the next step is use Excel average function to average the speeds you calculate in. Let me do it once. Okay, he says use as function of average to convert this distance, this speed given in kilometer per hour and find the average value. So I'm writing average speed. So we can find average speed using the function of average. Just type average and select these values. It will give you the average speed of the distance given of the ship, distance traveled by the ship. Second, he asked us to use the standard deviation function and find the standard deviation. Okay, standard deviation. Here we can type STDEV. This gives standard deviation of this data. Just select the data and see we have the values of the average speed. This is the data of standard deviation. Now highlight the cells you have numbers in and copy into the Word document. So just highlight them. Let me highlight this by different color, like I highlighted in this color. Highlight this into a different color. Let's suppose I type this. Highlight this into a very different color. Let me type like this. These two are the actual values we need. So I am taking it as a bold and giving them a color of yellow. Yeah. We can also format in like this. These values are given in higher numbers. So let me make them into a 3 significant figure numbers. We can convert this distance into a 4 significant figures. So let me do it in a 4 significant figure manners. We can convert time into a 3 significant figure. We are given 3 significant figures in the data. So let me convert into 3 significant figures. We can convert speed into also a 3 significant figures like this. When we do this, we should convert this into a 3 significant figures like this. So once, yeah. So we have the data in 3 significant figures. Just copy the data, Control C, and place it, put it in the Word document. So this is the data. Let me make this layout a little fancy. So this is our data. We have this speed. We can also convert like this. Don't do any changes. Make it a simple one like this. Okay. So we have this data available. We have the average speed, we have the standard deviation, we have the speed given converted from nautical miles to kilometers. Distance converted from nautical miles to kilometers, time converted from minutes to hours. And when we divide nautical miles, distance in kilometers to time in hours, we get the speed in kilometer per hour. When we take the average, using average function of the axle, we get average speed, and using the standard deviation, we get the standard deviation as the DE function is used to find the average speed, find the standard deviation of the speed function. Okay, next he asks us to construct a scatter plot of your distance in kilometers and time in hours. So we need to plot. How? We have the option here in insert scatter plot. So let me do this. So nothing is there. So here we have the option of select the data. We need to add the entries. We need distance versus time. On the horizontal axis, we will take time, and on the vertical axis, we take kilometers. So time on the horizontal axis, like this, select the values. On the vertical axis, we see distance in the kilometers. So just I plotted. Just when I click OK, see we have a scatter plot between distance and the time. Select this data, click, right click. Let me right click and add trend line. Your professor asks to draw a linear trend line. So select linear, click display equation on chart, display R squared value on the chart, close. So you have this equation of the trend line. We also needed the values which we chosen on the horizontal axis, which is time. So we need to mention the time. So we give title of horizontal axis as time in kilometers. Similarly, we have to give vertical axis a title. So I am given distance distance in kilometers, and time should be in hours. So let me change it. Time should be hours. Yeah. Time is in hours, distance in kilometer. We have this scatter plot with linear trend line. Just copy it here and place it on your Word document like this. So we have to drag it so it can becomes a little more clear. And okay, that's it. In the next step, after the plot, he asks, use your plot to determine how far in kilometers the ship would go in 0.8 hours. So we have the trend equation. The trend line equation is as follows. You can see this equation, y is equal to 41.035. Just mention it. I am putting in the equation form. Y is equal to 41.035x plus 1.8016. We have x as the time. So let me change it to a t. And we have y is distance. So let me change it to d. Now put time equals to 0.8 hours. We have given t equal to 0.8 hours. So just replace t by 0.8 and find the distance traveled in the kilometers. 41.035 multiplied by 0.8 plus 1.8016. So it becomes, let me change, try a calculator. So it becomes 41.035 multiplied 0.8 plus 1.8016. So we have the distance traveled equal to 34.63 kilometers. So in 0.8 hours, the ship travels the distance of 34.63 kilometers. Finally, just we need to convert this document into a PDF form. So let me print it into a PDF form and write whatever the name, introduction to Excel. That's it. So we have this all the data available in PDF form. We just converted distance in nautical miles to kilometers. We have the time in minutes. We converted into hours. Divided distance by time, we get the speed. We're using the Excel function of the average. I get the average speed. Using the standard deviation function, I get the standard deviation. Using the Scatterplot function, I got this distance versus time graph and find the trend line. Using this trend line, when I put t is equal to 0.8 hours, that is in 48 minutes, the ship travels 34.63 kilometers. 0.8 hours is equal to 48 minutes. As we have the time in hours, so we use 0.8 hours. We should not use the time in minutes. Thank you.